Let's go ahead and graph this parabola. And a parabola of this form is actually a function. So instead of saying y, I'm going to go ahead and bring back function notation. This is of the form f of x is equal to a times the quantity x minus h squared plus k. And remember that the vertex is being represented by parentheses h comma k. The thing that we have to do here is actually complete the square. If we complete the square, we could make this look like it in its graphing form where we could identify the vertex. So why don't we do that? First, rename y to be f of x is now equal to, I'm going to focus on x squared minus 10x, and I'm going to leave a space there. We'll put a gap here. I'm going to put plus 22 here, but we're going to complete the square right here on the x squared minus 10x. So remember, how do we complete the square on, let's say, x squared plus beta times x? Well, you take your beta divided by 2, and then we want to add beta over 2 squared. And that will help you complete the square, and it will allow you to factor a perfect square trinomial. So our beta is actually 10. Take 10, divide by 2, you actually get 5. Take 5 and square it, we get 25. So add 25. I should mention that it doesn't matter if it's plus beta x or minus beta x. It could be minus beta x also, and you would still add beta over 2 quantity squared to complete the square. Okay, so the first thing is take beta over 2, and then the second thing is take beta over 2 and square it. All right. Once again, take 10 divided by 2, you get 5, square it. We're going to go ahead and add 25 here. Now, that's illegal because we need to make sure it's equivalent to the previous expression over here. So we can't just add 25 to this expression. Instead, what we're going to do is add 0. And how do we add 0? Well, now we're going to take away 25. Because if you add a 25 minus 25, you just added 0. So now we're in great shape. Let's rewrite this. F of x is now equal to the quantity x minus 5 squared. That's exactly why we complete the square. Minus 3. Now we could identify the vertex. And the vertex is really key. It's going to be parentheses 5. Negative 3. So the vertex is actually in the 4th quadrant. Now we need to graph 2 ordered pairs to the right and to the left of this. So why don't we make a t-chart and start labeling those ordered pairs? Let's say x here and f of x here. Let's try 3, 4, right? Then 5, we already know the output for 5. The output for 5 is negative 3. And then why don't we try 6 and 7? And then, of course, all you're doing here is evaluating. You could go back to this function here and evaluate, f of 3. I'll do one of these, and then so that you get the hang of it. F of 3 is going to be what? F of 3 is going to be quantity 3 minus 5 squared minus 3. So that's negative 2 squared, which is 4, minus 3, which equals 1. So that gives you 1. And if you do 4, well, we get positive 1 minus 3, so we get negative 2. And if you do 6, we get negative 2. And if you do 7, we get 4 minus 3, which is 1. So let's plot all those ordered pairs. Let's graph the vertex first. So I'm going to put another quadruple star there because I'm going to graph the vertex first. That's really, really important. 5, negative 3. 1, 2, 3, 4, 5. And if you have graph paper, make sure you use it. You know, graph paper is going to help you. Always draw your own graphs and label your own graphs. That's really important as well. It helps you better understand domain and range. So don't use some kind of electronic device. If you want to learn algebra, draw your own graphs. Drawing is a mathematical skill. 1, 2, 3, 4, negative 2. Aha. And then, of course, we have 6, negative 2. And then we have 7, 1. And then we have, what, 3, 1? Yeah, and then we play connect the dots. Draw a U shape opening up. Make sure you put arrows at the end because you do want to match the domain and range of this function as well. Let's circle the graph. And let's circle your labels. And I put my labels in a T-chart.